Alright, hello. This is lesson 7-6 for geometry, coordinate plane word problems. Today's date is Tuesday, April 21st, 4/21, 2020. Our objective today is to use the distance and area formulas to answer questions about the real world. The thing that we're going to be using most is the distance formula. What is a distance formula? There's two equations. The first equation that I tend to just memorize is the change in x squared, and then I add that with the change in y quantity squared, and then I take the square root of that entire quantity. This comes from the Pythagorean theorem, if you remember. Another way that you can write this, the one that I'll probably be using more often, is just x2 minus x1, that quantity squared. Again, that's just the change in x, right? Plus y2 minus y1, the change in y squared, and then square root that entire quantity. Whichever one you want to memorize. I always memorize the one in blue and then kind of derive the one in orange. So example 1, we have a Clash of Clans example. So we have a defensive archer tower, and it's going to attack the closest troop. So we're going to assume that the archer tower is located at the origin, and I'm going to ask which is it going to attack first. Is it going to attack the balloon, barbarian, archer, or giant? And those are the coordinates of each of those troops. So this is kind of a nice problem because I'm at the origin, or the archer tower is at the origin, and the origin is at 0, 0. So you can think of our y1 or x1 is 0 and 0. So this value and this value are both 0, so it makes the problem really easy. Essentially, 7 is my change in x, 6 is my change in y, so I don't have to do anything sophisticated. I'm really just plugging into my blue equation here. So when I do that, I have 7 squared plus 6 squared, and I take the square root of that. 7 squared is 49, 6 squared is 36. Doing a bit of mental math, 4 plus 3 is 7. It's going to go up to 8 because I'm going to add 6 and 9 and get 5 and carry the 1. So square root of 85. And then I'm going to compare that to all of these. I'm going to leave them with square roots. Even if I have like the square root of 81, which is 9, I'm just going to leave it as square root of 81 because if I just compare radicals, I can tell which one is bigger really quick. So the barbarian, let's do the 4 squared plus, it's technically negative 8 squared, but again, anything squared is always going to be positive. So I should have that squared. 4 squared is 16 plus 8, oh, I don't know what I'm about to say there, plus 64. And when I take the square root of all of that, so I'm going to have 80, square root of 80. Okay, so far the barbarian is probably going to be shot before the balloon because it's closer, it's a smaller number. Let's check the archer. So we have negative 1 quantity squared plus 9 quantity squared, and then the square root of that entire quantity. And that's just 1 plus 81, and that's the square root of 82. Okay, so still the barbarian is the closest. Let's check the giant. And how are we going to do that? So it's going to be this negative 3 quantity squared plus negative 7 quantity squared. And that's supposed to be a square root there. So it's going to be 9 plus 49. And you can see that it's really close to the balloon in terms of the numbers that are coming out. It's slightly less than the 36. I have a 9 now. And 49 plus 9 is 58. And that is clearly the closest. It's the smallest number, so the answer is D. Alright, let's try a different example. I would say like half of them are a problem where it's like if you're in a certain range, or if you're just looking for the closest one, kind of like these problems, and then the other half are area or perimeter problems. I gave you an area problem because I thought that was harder than a perimeter problem. How do we do this? So let's read first. The Lee Vining City Council is trying to decide which building takes up more area, the water tank or the garage. So I don't know which one is which. Find the area of both the water tank on the left. Okay, so this red circle is the water tank, and the garage, this blue rectangle on the right. And I'm just comparing the areas. Which one has a bigger area, a larger area? Okay, so how are we going to do this? Well, I have to have the area of a circle and the area of a rectangle. So as a reminder, the area of a circle is pi r squared. The area of a rectangle is just base times height. And I know that some of the problems ask about perimeter or circumference, so just as a reminder, you'll need this maybe for Khan Academy, circumference is 2 pi r. We don't need that for this problem though. So let's jump into this red circle. What is the radius? And looks like it's pretty clear. So that the center here is at -2, 2. The radius is 3. So this radius up here is 3. So the area of my circle, maybe I can do this in red so it makes it more clear. Area of a circle is pi and then r squared, which is pi times 3 squared, which is equal to 9 pi. Okay, well, since we're going to be comparing two areas, we might want to actually approximate what that is. 9 pi is approximately 9 times 3.14. So let's pop over to Desmos, desmos.com/scientific. What is 9 times pi? And I might as well zoom in here. 28.27. So let's say that is, did I type that in right? Yeah, 28.27. All right. And what about this rectangle? That's the harder bit to do. So I have to find the length of this. I'm going to call that maybe the height, and then the length of this. And then once I find those two lengths, I just multiply them together because that's the area of a rectangle. How do I find those lengths though? And it comes back to our original formula up here. It's just the distance formula. So what is the distance from the coordinate 2, 4 to the coordinate 5, 6? Well, that's a distance formula problem. So let me do my work in blue here. So to find, I'm going to call that my height and my base. I could have switched those two. I'm just randomly assigning values here. I could have called this star and smiley face, but how do I find h? So h, the distance is going to be from the x coordinate is 2, the x coordinate is 5, so it's going to be 5 minus 2. This is the change in x, and then I'm going to square that, and then I'm going to add that to the change in y. The change in y, I went up 1, 2, so that's going to be 2, or I could have just counted squares 1, 2, 3, right? What I'm really doing is I'm taking the y coordinate of this point, the y coordinate of this point, 6 minus 4, showing all my work. 6 minus 4. I think it's way easier to just count the squares. I'm doing too much work here. And then take the square root of all that. That's our formula. So what do we have here? This is going to be 3 squared plus 2 squared. And that's going to be, I'm running out of room, 9 plus 4, which is the square root of 13. Perfect. Okay, so what about the b? So b, well, I'm going to count squares this time. I'm not going to do so much work. So I'm going from 4, and then the change in x, I'm going to go to the right. So, and you can, oops, stop. Okay, so you can see that I'm going from here, 1, 2, 3, 4, and then I get to this point down here. So my change in x is 4, so it's going to be 4 squared plus, okay, my change in y, I go down 1, 2, 3, 4, 5, 6, and I get to the height of that other point. So my change in y is 6, so 6 squared. And that's going to be 16 plus 36, still being square rooted. And what is that going to be? That's 52, and then square rooted. Okay, so I'm going to multiply the square root of 13 times the square root of 52, and this is where we probably need a calculator. I'm just going to do the decimal approximation, so I can say that the area of the rectangle is equal to base times height, which is the square root of 52 times the square root of 13. And calculator save us. The square root of 52 times the square root of 13 is, oh, a nice number. That's cool. So 26. 26. And we're looking for which one is bigger. Which is it, 28 or 26? So 28 is bigger. So my final answer, I'll write this in maybe a different color. The water tank, I think, was on the left. So the water tank has a bigger area. And I'll box my final answer. Boom. And that concludes the notes. I'm curious, though, just as the mathematician, why did we get such a nice number? Why do we get 26? Oh, okay, so I think I see it. You could totally stop watching at this point. I'm just curious. So 52, I think, factors as 13 times 4. But let me just check that. So is 13 times 4, it is 52, which means this is really 13 times 4 times 13. So this factor, if I multiply these two numbers together, this is 13 times 2 times 2 to get 4 times 13. And that's really equal to 13 squared times, I don't know why I said plus, times 2 squared. And when I take the square root of all that, I'm left with 13 times 2, and that's why I got 26. Interesting, cool. I'll remember that 52 has 13 as its factor more in the future. Cool, and that concludes my official video now. I'll see you guys tomorrow.